Hello, everyone. You're welcome back again to our math journey. And in this journey, we want to make math easy and comfortable. If you are new to our channel, please do me a favor by subscribing, liking this video, and sharing it to as many people as possible. If you have specific topics that you want us to do a video on, feel free to drop it in a comment section below. All right, today we are going to do an entirely different topic, and the topic is algebraic expression. Algebraic expression. It's one of the topics that is the foundation for doing things like equations and difficult problems. Now, algebraic expression was propounded by Francois Viette. Francois Viette in the year 1900 to 1600 BC before Christ. So it was propounded. It was propounded by Francois, or I think I cannot pronounce it clearly, but I think is this how the spelling is? Francois Viette, Viette. I think a French name, Santegu. And then in the year 1900 to 1600 BC, which is before Christ. Okay, algebraic expression. Now, what are they? Algebraic expressions, they are expressions that involve they involve numbers. So it's an expression that involves so the first thing it involves is what? Numbers. It has numbers. So whenever you see an algebraic expression, you'll find numbers in there. You will sometimes also see some things like variables like alphabets, theta, phi, pi, alphabet A, B, C, and all manner of variables. The other thing that it has, or it possesses, or it involves, there is no equality sign. You don't find any equality sign in the expression. It's called algebraic. That's why it's called algebraic expression. If it's an equation, algebraic equation, then aside seeing numbers and variables, you'll surely see an equal to sign. But this one, we're discussing algebraic expression. So you'll find numbers, you'll find variables, and then you wouldn't find an equality sign. So there is no equality sign. Now, when we say numbers, you're looking at 1, 2, 3. Those are numbers. Variables, you're looking at pi, you're looking at, maybe theta, you're looking at A, you're looking at B. No equality sign. This one here is called there is no. It's a mathematical symbol for there exists. There exists no equality sign. So algebraic expression was propounded by Francois Viette in the year 1900 to 1600 before Christ. And it's an expression that involves numbers, variables, and there's no equality sign. Now, there are a few rules. There are a few rules that I want to point out for each and every one of us. Few rules. So, some few rules that you and I need to look at for. First rule is that if there are same variables, we can add and subtract them. So when there are same variables, we add and subtract. So we can add or subtract same variables. So example for such a rule, example is, if you take an example, we are looking at maybe minus 3x minus 5x. So here we can see that this x here and this x here are same variables. So we say same variables. So since they are same variables, we can add or subtract them. Now, if we look at what we have here, this is negative 3. This is negative 3. And then that is negative 5. Don't forget the sign that comes before the number is a sign related to the number. So what we can do is that we can subtract. We can be able to subtract. So first, we can subtract. We can take negative 3. We can have negative 3, negative 5. And don't forget, remember the last time we said that anytime you have a negative number, it's like owing someone, So in this case, it would be owing $3. You owe $3. We owe $3. And then here also, it means we owe $5. So technically, these funds are not from our wallet. So to pay back these debts is going to have a total of $8, right? And that's a debt, so it's negative 8. So we can be able to add and subtract the same variable because 3 and 5 are numbers. Oh, sorry, because negative 3 and negative 5 are numbers. And what type of numbers? They are negative integers. We can be able to work on those quickly. So negative 3, negative 5 gives us negative 8. And because they are the same variable, we're just going to repeat. We're just going to bring the variable. We're going to attach the variable to it. So let's look at it again. We're saying that if you have negative 3x minus 5x, we're going to have this and this give you negative 8, and then we attach the x to it. So you're going to get negative 8x. I hope this helps. But I'm going to do a few. We're going to take few maybe examples to see. So let's wipe the board, and then we'll take a look at a few examples again. All right. So if they have the same variable, if it's the same variable, you can add and subtract. If you're joining us and you haven't subscribed to our channel, please do us a favor by subscribing to our channel, liking the video, and sharing to as many people as possible. The goal of this journey is to make math enjoyable. That's why we are a family, or we are in this class together. Now let's get back to what we're talking about. Imagine you have 7x squared plus 40. Okay, if we have this, now remember, we have 40, which is a number, is a positive integer. We also have 7. We cannot add it. Why? Because this 7 has x squared attached to it. Here, there's none. So we can't do anything to it. But if we had something like 7x squared plus 40x squared, then for sure this and this are the same. So we can add this 40 and 7. So we get 47. And then we can attack the x squared to it together. All right. So let's think about the variable, this x squared. Think of it like an orange. So you have 7 oranges plus 40. You cannot add oranges to nothing, right? You cannot do that. So we can also interpret it as such. All right. Now, let's look at another rule. We're going to look at another rule. Look at the first rule. The first rule says that if the variables are the same, we can do something we can add or subtract. Now, the next thing is to multiply any variable. So rule number 2 says that we multiply any variable. If there's any variable, you can multiply any variable. So it doesn't matter the expression, multiplication can actually go on. So let's take a look at that example. We have 7x squared multiplied by 40. Now here we are saying that it doesn't matter. It doesn't matter what this 40 is attached to. It doesn't matter this. We can still be able to work things out because the sign here is multiplication. So it means we can multiply any variable. So what we're going to do is we have 7x squared multiplied by 40. We are going to multiply this 7 by the 40. So we're going to get 40 times 7, and then we attach the x squared together. So we're going to get 40 times 7. Now 7 times 0, 7 times 0 is 0. 7 times 0 is 0. 7 times 0 is 0. And then 7 times 4, 7 times 4 is 28. 7 times 4 is 28. So we get 280. 280. So this 2 gives us 280, but we have to attach the x squared together. Now let's look at another one. I'm going to take another example. Let's say we have 7a times 4b, for example. We can multiply this and this to give us 7 times 4. And we can also multiply the a by the b. And we're going to get this is going to give us 28. And then this 2 is going to give us ab. And then we can attach it and get there 28ab. So for multiplication, anything goes. Anything goes. Anything goes at all. All right, let's take a look at another one. We have, let's say we have 7x squared multiplied by 4p. Okay, we can multiply this by that, which is 7 times 4. We can multiply that together times the x squared times the p. So I think if you multiply this and this, you're going to get 28. And then if you multiply this and that, you're going to get px squared. Px squared, we're going to attach them together and get 28 px squared. So for multiplication, you attach them together. What we mean by that is if you have something like, let's say we have AB multiplied by M, we just bring them together, we attach them together. That gives us ABM. If we have, let's say, A squared N multiplied by, let's say, PY, we're going to attach all of them together. We're going to get A squared N PY. So for multiplication, everything goes. But for addition and subtraction, we have to be mindful of the variables that attach to the numbers. Those are the things that we just have to be a little cautious and a little mindful of. So now we're going to take a last problem, and then I think we'll bring our video to a close, and then maybe later we can get more questions to delve deeper into algebraic expression. So let's imagine that we have this problem. Let's say we have 7x squared minus 3x minus y minus 2z plus 4p minus 5x. We're just going to imagine this is a question. Now remember, algebraic expressions do not have equal to sign in the mix. So to start such a problem, we need to introduce an equality sign. So it's equal to 7x squared minus 3x minus y minus 2z plus 4p minus 5x. Now remember, we said that when we are adding or subtracting, the variables have to be, the same. The variables have to be the same for the addition or subtraction to work. If the variables are not the same, the only time that works is if we are multiplying. If we are multiplying, then yes. Otherwise, we cannot do anything about it. So in this case, we are doing a lot of subtraction and addition. So we should be mindful of the variables that are coming together. Now, look at x squared here. This is the first variable. Do we have any x squared in the expression? No. If we look at the next one here, is x. The variable there is x. Do you have any other x? Yes, we do. It's right there, the x. So we can bring that one together. And to do that, we can have 7x squared here minus 3x. And then we bring this negative 5x to it. So it's going to be minus 5x. Whatever sign is here, we bring it closer. So that gives us minus 5x. Now, if we look at y, there's nothing. If we look at z, there's nothing. Look at p. So we're just going to indicate that in our work. So we're going to have minus y is going to be there, minus 2z is going to be there, plus 4p is going to be there. And we need to simplify it. How do we simplify that? It's equal to 7x squared. These two, we need to simplify these two. Don't forget, this is negative 3, and this is negative 5. That gives us negative 8, and then we bring the same sign there, which is x, same variable, which is x. Now we're going to bring minus y, minus 2z, plus 4p. All right. So this is a simplification of the algebraic expression that we're able to get. I hope this video did a lot of good. If you haven't yet subscribed, please do us a favor by subscribing to our channel, Tutoring Made Easy. Like it, and share it to as many people as possible. I will come to you another time. Take care.